So this week we've got the Gym Aware Power Lab that you guys are going to be doing. Now it's power maintenance, so we're looking at doing multiple repetitions of movements. If you guys would like to try to do it on your own, we do have the Gym Awares in the lab. So you guys are more than welcome to watch the videos on YouTube. And then you guys can obviously come in. We'll hook you up with the GymAware device. You can go and do your own testing and then bring those results to class on Friday. Otherwise, no worries. You guys are going to be good just following the data that you see online and writing it up appropriately. Now, if you guys don't have any questions, you guys ready to go ahead and try our little scenario that we got for the day? Love the enthusiasm. All right, so today, effectively, your scenario that you guys are going to be working with is going to be if you were able to customize the body completely for an ultra marathoner, okay? And we're going to answer each of these questions. Now we're going to do them one at a time, okay? But I'm going to give you guys about 5-6 minutes each. And then we're going to go ahead and break down each of these questions. Now, don't be afraid to think outside the box, but I want you guys to write something up that you're going to be able to go ahead and paste on in. So any questions, comments, concerns before we have you guys go ahead and go into those wonderful breakout rooms? Okay, Trendon, what question can I answer for you?
I don't really have a question.
Okay, sounds good. So have fun with it, but make sure you thoroughly think through all the different aspects of muscle physiology. There's more than just fiber type. Think about the mitochondria inside, think about the macronutrient stores, think about certain things like the satellite cells around it. What do we want to see? Maybe the fascia and the connective tissue. So have fun. See you guys in a few moments. You guys are going to have 6 minutes. All right, guys. So John's group's posted theirs up. You guys might not see it because you weren't in there yet, but great point with you want a great amount of type 1 fibers. Be careful when it comes to, yes, Catherine, when it comes to your type 2 fibers in the core, you wouldn't want that because it turns out your core is going to have to be firing the entire time. So you're going to want to actually have a greater amount of type 1 component in your postural muscles, which you actually already normally or naturally do. Along with high mitochondria, awesome, same with proteins for metabolism. The one thing you also want to have is a greater amount of glycogen storage and intramuscular triglyceride storage. And I do like your points on the tendons to deal with the greater amount of impacts and also give you a greater amount of elastic recoil, which actually improves your economy of effort and requires less energy to do the same amount of output. Yes, tall with long legs. Good job, Catherine. Yes, and a great amount of satellite cells, so that way you're going to be able to recover faster and, yeah, make those adaptations. Good, good. Okay, Braden, what else from your guys' group? We would probably also want to have really, really good development of our ability to shuttle lactate from one cell to the other. So that way we're never going to have that lactate accumulation. That would probably be another component. But otherwise, yeah, guys, you're hitting all the major high points there. So any questions over effectively the first question there before we get into essentially the bone structure, which actually Catherine's group already essentially touched upon. We won't go into groups on this one because it's a pretty straightforward and easy one, but what other changes might you want to see? Just the first question, Braden, just the first question. You'd want to have a narrow body frame, but would you want to have somebody who's tall or short? Yes. Long legs or short legs? Long arms or short arms? Yeah, potentially either. Maybe actually short arms, because there would be less mass in the upper body along with a shorter torso, less mass in the upper body, so it'd make you even more efficient as a long distance runner. Yeah. Now, outside of that, obviously, we want the bones in the lower body to be dense, well, as dense as they need to be. So we don't want to be so dense that we're actually going to have a heavier skeleton. Not that your skeleton is ever really that heavy, but we obviously don't want it to be too brittle that you could risk injuring yourself. Like birds are a great example of an organism that have got hollow bones. And so birds, specifically ones that fly, they have issues with easily fracturing their bones because their skeletons are just so brittle. All right, so are you guys ready to get into groups talking about the endocrine system? I will take that as a maybe. So, thank you. I appreciate the feedback, John, because I feel like I'm on my own here. No. Have fun, guys. And actually, let's not just do the endocrine system. Let's get into the cardiovascular system. So remember, you need to be breaking down not just the heart, but the blood and the capillaries. Make sure you're getting into that, okay? See you guys back, and we'll go 8 minutes this time. So plan on coming back at about 1:50. All right. Yeah. Catherine's group, great job. The only thing I would maybe add is also increasing the capillaries in the heart, just so it can has a little bit easier function. Otherwise, that's great. Okay, maybe not necessarily want to have a great amount of epinephrine, trenin, probably just enough to keep yourself going. Yes, erythropoietin, increased red blood cell production is absolutely correct. Appropriate use of ADH and aldosterone. Yeah. Don't forget that also testosterone is going to be important in recovery as well. Yes, better vasoconstriction, as long as you're not going to the point of which you're going into ischemic events and possibly having something rotten fall off of you. But otherwise, absolutely, looks good. Yeah. Yeah, guys, good job. Good job. All right. So now we're going to talk about some different realities. So if you've got to do this race in 100-degree weather, now I'm talking about the body itself. What would be some things you would want to change, modify, optimize, aside from they're going to be out there in minimal clothing, they're going to try and stay in the shade, the basic tactical decisions you'd expect. But I want you to think about the physiology. What are some things that we'd maybe try to modify, things we would try to approach a little bit differently, so we would go ahead and have a little bit better performance, a little bit better tolerance of the heat, for lack of a better term. And it's okay to get weird. And it'll make sense when we come back, when we talk our way through it. So questions, comments, concerns before we go in there, guys? All right. Have fun. Get back at it. So I forgot to hit record when we did that last one. So this is just saying what we just said, where the groups did a good job of pointing out the fact that we want to have a better job of sending blood flow to the skin. We want to have a lower amount of body fat. We'd also would want to have longer limbs, spindlier limbs, so a greater amount of surface area to mass ratio, maybe massive ears, so that way we can do an even better job. Be able to do some hyperhydration, do a better job of effectively retaining excess fluids before we start going on our long run in the heat. So that would be something like trying to effectively or not wear, sorry, but we would try to use things like glycerol, maybe sodium loading, but otherwise maybe have some hormonal effects with aldosterone and antidiuretic hormone to hold way more fluid volume than we'd really hope. So that way we're going to have a better amount of fluid to hydrate or to dehydrate with, and along with, we would want to make sure that when we are sweating, we're doing a very good job of minimizing our electrolyte losses to the greatest extent of our ability. So we're not going to have issues with potentially cramping as we go later on. So they did a great job. Yeah, overall, guys, great work. I like what you guys came up with. If we really wanted to go and make it weird, we want to have a human long distance runner that looks about as much like a penguin as possible. So real short arms, real short legs, real broad torso, effectively, a body that looks like a bowling pin about as much as possible. So that way we're going to do a better job of retaining heat. So yes, otherwise wearing appropriate clothing and doing what we can to conserve heat, making sure that we're not going to be wet and otherwise, but yeah, good work. Any questions, comments, concerns about this basic little foray we did into effectively how we try to optimize given different situations? I do like the higher level of T3 and T4, John. That's good. We could also have more brown fat, which is fat that's metabolically active, but doesn't actually, it just burns energy to create heat. Nice. Now, what I've got up here, guys, is a chapter that we're obviously not covering too much in the direct class, but it is something that at least is worth highlighting, which is just a little bit of gender differences when it comes to working, or sex differences when we're going in sport. Because I know sex and gender are two, the different constructs, and there's variability in each. So there's always going to be, we're speaking here on averages, not on the actual specific differences. But is there any questions that you guys have when it comes to differences between the two genders, when it comes to effectively working with male athletes or female athletes? Nope. All right. So that's everything that I really wanted to go ahead and cover with you guys today. Now, I am going to stick around myself and just kind of talk on this topic for a little bit. You guys do not need to hang in the lecture if you do not want to. So otherwise, have yourself a great day, and I will see you guys on Friday for discussing the gymwear lab. If you guys want to go ahead and use one of those units for your own, so you can do the lab on your own, you guys are more than welcome to. I'll show you guys how to set it up, and you guys can take it to the rec, use it appropriately. Do keep in mind that each of those devices is worth about $2,500. So we do not want to be cavalier with their use and or break them. And otherwise, yeah, have yourselves a great day. And then I'm just going to talk a little bit about differences between men and women. So stay safe out there, guys. Talk to you more soon. Now, when it comes to differences between the two genders, whenever it comes to sport and exercise, what we're going to find in general is a lot of lies, and that women aren't as good as men at different physical activities. When in reality, yes, you're going to find typically about anywhere from about a 1 to maybe 10% difference in performance between men and women, but that's the best of the best, which means within that, a number of those women are beating a lot of the rest of the men on the planet. And so when we're talking about differences, yes, they do exist. It is going to come down typically down to muscle mass differences, and fat mass differences is really how it's going to select between the two. Now, the bigger reasoning for it is really coming down to testosterone. So for us gentlemen that do have it, it's going to go ahead and increase our total amount of not just our bone mass, but also our lean mass. and in turn help us increase our red blood cell production. So a little bit of a boost to our performance, whereas higher amounts of estrogen leads to a greater amount of our total amount of body fat, along with our differences in bone growth, and in turn, leads women to typically be shorter than men. Now, notice, guys, when we're looking at the units here, yes, it looks like women have a much higher spike in estradiol, but notice that the graph is from effectively 0 to 700 nanograms per milliliter, and then we go to nanograms per deciliter. So literally, that is it's a 10x difference. So in reality, women and men both have more testosterone than they have estrogen, irregardless of gender. However, men notice have a markedly higher amount of testosterone compared to women on average, and the same is said when it comes to women. So there are relatively distinct female body fat distributions. Just look at your average woman compared to your average guy. Women are going to carry more on their hips and thighs than your average man, along with, obviously, you have some gender differences. Now, this is thanks to hormonal effects, once again, coming down to estrogen and gender levels. And this also is the reason why regional effects can be relatively difficult. Where you store body fat is very genetically programmed. So where you're going to lose body fat from first and to the higher level, that's going to, once again, come down to, sadly, who mom and dad are, along with, obviously, how much you've managed to accrue. So that's going to be not just fat cell size, but number. And the problem is, once you increase the fat cell number, it's much, much harder to get them to go away, so to speak. And so they're effectively just there, but they're smaller, just waiting effectively so that they can increase in size again. Now, when it comes to the muscle strength differences between the upper and the lower body, the key difference there is more in the upper body, where it seems that our upper body musculature has a greater amount of sensitivity to the androgen receptor. So you're going to see, on average, a female is going to be about 40% weaker than your average male. Where it comes to the lower body, the differences are going to be much, much smaller. We're talking, you're going to have women that are about 3/4 or so. And a lot of it, once again, is due to muscle mass, not that men's muscle functions differently than women's muscle. They're going to both be functioning the same. You will find, in general, when it comes to the actual like male muscle fiber to female muscle fiber, when you're looking at the same cross-sectional area, there's no difference in force production. The key difference is guys typically have more muscle mass. Now, there's a number of reasons why we're going to have the upper compared to lower. A number of these are going to be, arguments based upon what's going on with, effectively, gender and at the same time societal roles. So it turns out guys, especially American guys, the bench press is the lift of the Mondays throughout the world, because we have to be really good at laying on our back and pushing something off of us. And whereas you don't see that same type of specialization and focus in a lot of women's athletics, though, if you ever see female gymnasts, it's very easy to see them that can bust out sets after sets of handstand push-ups, and how many guys would have a hard time doing it. So at the end of the day, cross-sectional area, fiber types are going to be pretty similar between the two genders. Guys have a little bit more predisposition to a slightly higher amount of type 2 muscle fiber, that would be type 1 muscle fiber than women. But at the end of the day, remember, 50% of your fiber type is determined by your genetics. The other 50% is determined by how you live your life. So obviously, the more that you're going to train and otherwise, the more you're going to see the shifting. And in reality, women seem to tolerate a higher amount of training volume, specifically when we're looking at things like resistance training and otherwise, compared to men, which is fascinating since men have the great amount of testosterone, which in theory would make it easier for them to recover from harder training. Now, when it comes to the cardiovascular systems, they're going to effectively be about the same, whereas on average, women will have a slightly higher heart rate and a slightly lower stroke volume, often going to come down to differences in body size. And due to that body size, women are going to have slightly smaller hearts and lower blood volume, which we'll get into menstruation in a little bit. Now, women are going to do a better job effectively of removing oxygen from the bloodstream than guys. That's that AVO2 difference, even though they've got a lower amount of red blood cells. And that's because women are on a monthly phlebotomy schedule, meaning thanks to menstruation, they're going to lose a certain amount of blood every single month. And that's not adding in any extra blood losses from a lot of long distance running or sports in general. Now, when it comes to respiratory, mostly just due to the fact that women have a smaller rib cage and had smaller lungs than men. And whereas women are in turn going to be breathing a little bit faster just because they don't have the same amount of lung volume, just due to the skeletal differences between the two genders. Now, in general, your average guy is going to have a higher VO2 max than your average female, and your highest level athletes, females are going to still be behind men in about that 1 to 10% differential, just simply because once again we've got those gender differences thanks to body composition and otherwise. Now, like anything else, this in turn is going to show itself also in things like our fat-free mass, size of our limbs, height, weight, etc. Now, as far as whenever we're talking about our total amount of body composition, once we do a true breakdown for that based upon body comp and athletic performance, there's not really a big difference between the two genders. It's more or less due to that body fat. Now, in general, when it comes to just acute performance, your average female has a lower amount of hemoglobin, so that's going to limit our VO2. They're going to have slightly lower VO2 max, remember, because they have that slightly smaller heart size, and we're going to not have that same amount of stroke volume. So yes, there's going to be a little bit difference. Women tend to have the greater amount of lactate production at effectively lower intensities than a guy. About the same intensity, but a greater amount of lactate is going to be seen in gentlemen, and arguably that's due to a little bit more of type 2 fiber type anaerobic metabolism. So when it comes to body comp changes, they're going to be relatively the same. The key is, since your average female is smaller, in turn, they're probably, if you're looking percentage changes, are going to be the same, but the absolute is going to be different because your average guy is bigger. Now, training in general is going to help increase lean mass, going to help improve body composition, and healthy diet or otherwise is going to decrease fat mass. Now, when it comes to injury, there doesn't really seem to be a big difference between the two genders. It's just something that's going to happen. In average, your females are not going to be effectively having as great of muscle mass as your male, and whereas a lot of the gains in strength is going to come from neurological efficiency and, once again, fat-free mass. So, not going to insult your intelligence, but reading the rest. Keep in mind that obviously, yes, there is a difference between men and women, but that difference isn't necessarily that great. And like anything else, it's going to be a fascinating game, since a lot of super high level performances are often done by athletes that are using substances to enhance their performance. And so effectively, if everybody's doping, then at the end of the day, the gender difference is really not going to be that big anymore. So this is just from things like the mile to the 5K, 10K, and marathon. And obviously, these are older records. These have since been broken in some of these endeavors. Now, obviously, you can have some particular differences between men and women. First one is going to be menstruation, which is a normal effect of being female. But obviously, depending on what stage of the cycle an athlete's at, it's going to influence their performance, can influence water retention, and can obviously also influence enthusiasm to train. Now, there's not a lot of good information on this because this requires really, really good data keeping and tracking of athletes. Now, as far as your ability to do a VO2 max or otherwise, absolutely fine. And at the same time, you have to keep in mind that there's a bit of a survivorship bias, because the ladies that have that hard of a time at certain periods of their cycle, they're going to not want to come in and do athletic testing. And because of that, you're not going to be able to really look into that difference as well as if they would have been able to effectively attend. Now, obviously, we can have some other issues, which is certain ladies can have a delayed menarche, meaning they're not going to have their first period until they're after 14. This can often be because of effectively a lack of energy intake compared to physical activity, and seems to happen, could be happening simply because there's certain athletes that gravitate to certain sports, but it can also be just due to the natural activities and requirements of the sport is delaying these maturations that otherwise would have occurred. And this seems to happen more in our very lean athletes. Eumenorrhea means we have a normal cycle. Oligorrhea means we're starting to have irregularity, and then amenorrhea is we don't have it. Now, this is something that can happen to certain athletes more so than others. Individual athletes that are doing a lot of calorie burning effectively in their sports. So our long distance athletes, our really high volume aerobic athletes that also aren't able to get enough calories can have some issues. Just because you're not menstruating doesn't mean you're completely infertile. However, we are talking about starting to have some effects on our hormonal milieu. And we did talk about before effectively of treating the human body like a spaceship and thinking about, well, if we're starting to tap into what is effectively a very accessory part of the human body, now we're going to be risking a lot more issues with health and wellness over the long term. So, like anything else, we want to make sure that our athletes are fueling themselves appropriately, and we're not just getting in enough calories, but we're also making sure we're getting in appropriate amounts of each of the micronutrients to support their health and performance. So, when we happen to be trying to exercise when we're pregnant, yes, you can be shunting a little bit of that blood away from the fetus itself, which could potentially lead itself into hypoxia. Now, at the end of the day, it isn't that high of a risk, but it is a risk. And it should be a situation where women that were not physically active pre-pregnancy should try to be a little bit physically active, but we shouldn't be doing maximal exercising. And at a certain point during a pregnancy, it's time to take a break. It's time to take it easy, and definitely no longer time to try to push and improve numbers. Now, this is something that still needs to go ahead and do more research so that we can really figure out what is an healthy and perhaps unhealthy level of exercise and exercise intensity for pregnant women. But like anything else, the major concern is the fact that this could lead to miscarriage. Hence, it's going to be very hard to ever get this type of research approved. So when pregnant, we want to be physically active. We want to make sure we're not doing a lot of laying down exercise just because of the effects on blood pressure and the positioning there. When you get to be fatigued, it's time to go ahead and take a break, not keep pushing. And as you get further and further along, you just definitely want to make sure you're not risking, falling over, landing in a bad position or otherwise. So making sure we're eating appropriately, we are staying hydrated, and this is way beyond the scope of any class like this whatsoever. This is one of the many times you need to go ahead and talk to a doctor. Now, osteoporosis is going to be incredibly low bone mineral density, which is something that can definitely happen to individuals that effectively are amenorrheic or effectively we're not getting enough calcium, vitamin D in our diet. And this is something that's more likely to happen to small women as they get to be older in life. So that's why it's so important to increase bone mineral density when you're younger and hold on to that for as long as possible. Now, there's a number of contributing factors here, and obviously eating disorders, unfortunately, are another situation that's going to cause this increase in bone mineral density. So hence, it is very important to make sure that we are having a good, healthy relationship with food. Now, what is fascinating is estrogen supplementation is shown to seemingly have some potential negative effects on health and not effectively helping just alleviate osteoporosis like was once believed. This is an area that still needs to be improved even more so. And then certain other drugs are out there as means to effectively keep the body from breaking down the bones. But at the end of the day, there's certain things you can always do, which is eat a healthy diet that has plenty of calcium and vitamin D, vitamin K, magnesium, all of our minerals and vitamins, along with making sure that we're physically active, doing weight-bearing activities, things that are effectively giving those signals to our bones of we need to stay dense because we might break. Because like anything else, if we don't have the signals of our body to maintain our structures, the body's going to effectively allow them to decay. Now, obviously, eating disorders initially was a gendered situation where they thought it was only with women, but it is very much so a situation with both genders. However, like anything else, it's the younger people that this is a bigger issue with. So the key is we need to make sure that you're not creating bad relationships with food, which is a very easy thing to do, or bad relationships with personal or self-image and otherwise. Now, this shows itself in a number of different flavors. We also have the men's equivalent of bigorexia, or where effectively guys never feel like they're big enough, so they keep trying to gain and gain and gain weight. specifically muscular weight, so that they can have a certain look. And like anything else, it's going to be a situation where it's just doing damage to the person and the relationships. So with certain sports where there's aesthetics, so you're in very revealing clothing, or there's very much so the sports about long distance efficiency, or your weight class, you're going to find a greater amount of risk for things like anorexia nervosa and bulimia to a lesser extent. Bulimia can be anorexia nervosa has the highest lethality rate of all mental illness, which is crazy if you think about it. Whereas bulimia nervosa, you can have a lot of individuals that are doing a lot of damage to their dentition, to their esophagus, and otherwise from vomiting, but they're going to present at relatively normal body weights. They're not going to be underweight. You're not going to look at them and think like, oh, they might have an issue. Binging and purging type relationships with food don't always effectively end with individuals being in a lower body mass than one would suspect. So these are really, really hard to deal with. This is something where you want to work with not just a dietitian, but a psychiatrist or psychologist, something so you can help this person work their way out of. Because like anything else, it is going to have a high risk of a lot of negative health outcomes for the individual. Now, some of these things can lead themselves into what is referred to as the female athlete triad. And this is where we have a rough combination of, thanks to not getting enough calories in, we then are going to have amenorrhea, we're going to decrease our bone mineral density, and potentially have effectively disordered eating being a component. It's a possibility, but like anything else, when all of these occur, we're going to have issues with under recovery and some major risks of some negative health outcomes. So when in doubt, increase caloric intake, decrease activity, and just trying to work for the overall health of the individual. Now, when it comes to differences in general, women are going to actually be a little bit better at cold weather stress just due to insulation. Guys get a little bit more out of thermogenesis from shivering, thanks to having a greater amount of fat-free mass. And where it comes to, in general, women tend to sweat less than men, but there's not really a big difference in our heat tolerance between the two. And the same type of situations where we're going to find with altitude, it's not really going to be a big difference. The key is if a lady happens to be anemic to start, that type of exposure to altitude is going to be even harder on their physiology than someone that happens to be essentially having a normal hematocrit. So thanks for listening, guys. Stay safe out there. Have a great day.